Hello and welcome to another video. So in this video we're going to be finishing up the on-site interview loop for all these things. So I think we just have the Adobe one left. So let's get started. Alright, so you're given strings jewels representing types of stones that are jewels. Each character. Okay, so how many of the stones are also jewels? Letters are case sensitive, so A is different. Characters and jewels are unique. I see. Okay, so basically, yeah, it seems pretty easy. Not really much to explain. Let's try to get some list comprehensions going this time, just for the heck of it. See what happens. So, turn. I think what we want to do is we want to go length of. Actually, no, we'd have to make a new list, so it actually would be bad. Okay. Yeah, fine. So if the stone is a jewel. Increment result. Yeah, actually thinking about it, list comprehension would be bad because we're just creating more space for no reason. Alright. Move the nth node from the end and return its head. Alright. Yeah, definitely remember doing this problem some time ago, and there's some stupid like 1-pass, 2-pass, 2-pointer, whatever. So we'll just go with like an easy approach. Like a 1-pass 2-pointer or a 2-pass is the same thing. And in general, I think linked list problems are some of the easiest because you just need to know how to like split a linked list, reverse, traverse. So yeah, so all we got to do is just let's see. We got to figure out the length, and then we got to figure out like how far to traverse to the node nth from the end. So let's say length is like L. So to remove a node, we have to be at the node before the node. So we have to be here. So typically you want to make a dummy node, so let's just start with that. List node 0 head. So we'll have this linked list of dummy, and that'll go to 1 to 3 or 2, 3, 4, 5. Alright, so if we start at the dummy node and we want the second node from the end, how far do we have to traverse? So we got to go 1, 2, 3. Yeah. So we got to go 3. We want second node. So I think we just need to traverse, like, let's just confirm length minus n. I think. So if we want like the fourth node from the end, that would be this guy. Here we would traverse once. 1. Fifth node from the end wouldn't traverse at all. Last node would be 1. So we traverse 4, 1, 2. Yeah, looks good to me. Alright, so yeah, I'm gonna do a 2-pass. So length 0, dummy, while cur dot next. Or we can do cur equals head actually in first. So while cur is a node, length plus 1. Alright. Then distance will be length minus n. Cur equals dummy. And then for this in range, distance cur equals cur next. So ideally we should be at the node right before the node to remove. And then the removal is pretty easy. We just make the pointer of the node we're at point to the node after the one we want to remove. Now, yeah. And the node after the one we want to remove can be null, but that doesn't matter. So we just go cur next equals cur next, and return the head. So the head might not be there. Like imagine this case. So in this case, length would be 1, dummy would go here. we're going to traverse 0 times, and then this node is gone, so this will point to null. So we just want to return dummy next, not the head. That's why dummy is useful. All right, okay. What did we do wrong? Let's see. For this test case, where's it? Okay. So let's print this just to see. Dist. Dist is 3. That should be fine. Okay, so cur. Oh, easy. There we go. Cool. Okay. Given an array of unique elements, return the power set. Solution must not contain duplicates. All right. Easy backtrack, right? Is this the easiest one we got so far? Yeah, so literal just standard backtrack, and at every point we just need to yeah, so at every point we need to put in a number. Now what happens if, okay, the elements are unique, so we don't have some weird, yeah, so literally just every point take whatever's in your current array, put into the result, and then standard backtrack, right? Yeah, I think so. Not much there to say. Okay, cool. Let's try to get a new best time for the fun of it. Index, index, index. So in the beginning, we're gonna say append cur copy. And the reason we're gonna append cur copy is because we're gonna be modifying cur all the time. So if you append, like, let's say cur is like 1.3, and you append that here, and then you modify cur, this will change. So we just want to take a copy. And I think the other way of doing it is this. Also works. This creates a new array. We can try this. Yeah. And then, so if I is length of nums, that's it. So return for j in range I nums cur append nums j backtrack. Yes. Cur pop. So do we always want to add a number, or so you could do this one of two ways. I'm thinking maybe the other way is easier, where we just either take or not take the current element and we don't loop at all. Yeah, I like that. That's usually easier. So let's go with that. So we're gonna say cur.pend nums I backtrack this one cur pop, and then do the other version. Now I think if I do it this way, we'll have the empty array twice, but we'll double check. We might change this around later. Okay. And then just backtrack without taking the element. All right. So let's just do a dry run. So it's this, curse this. All right, and then we'll see if we have to modify anything. We might have to modify one thing, but let's see. Yeah, because I think there's a case where we take nothing, and then that might screw it up. But let's see. Okay, so oh, actually, we can fix that by doing this. I think that should solve our problem, but let's just see. So we're only going to append when we get to the end. Okay, so the numbers are 1, 2, 3. So we're going to append 1, recurse. Now we're going to be at 2. Append 2, recurse. Going to be at 3. 3, take. Okay, so we take this, put into the result, recurse. Now we don't take 3. Put that into the result, recurse. Okay, so now we're done with this case. Now we're not going to take 2, and then we will recurse to 3. So we'll take 1, 3. And then we won't take 1, 3. So it's this. I think those are all the combinations with 1 at the front. So then we'll do the same thing with, we'll go to 2. So 2, then we'll take 3. And then we won't take 3. And then 3. Alright, there's only 2 numbers, 2 at the front. Yeah, okay. 3, go like this. There's nothing behind 3, so that's it. And then we won't take 3. Take 1, don't take 1. Yeah. Can we get to the thing where we take nothing multiple times, actually? So, like, if we don't take 1, and then we don't take 2, and then we don't take 3, is there another way of doing that? I don't think so. So, yeah, 3 basically will take, yeah, so we won't take 1, we won't take 2, and then it'll look like this, and then, yeah, I think 1, 2, 3, 4, 6, 7, 8. Yeah, I think this is good. Let's go for it. So I'm just call backtrack. 0. Return that. Alright. Right. I think that was a medium. Definitely not hard. Yeah. Okay. Yeah, maybe I was a little bit cautious on that one. Yeah, definitely the easiest one I've done so far. Haven't done this one before. Have done this one, but basically every linked list medium is like super easy. You just do some traversal, and then yeah, all you have to know is how to, like I said, split a list, reverse a list, whatever. Even hard linked list problems, it's literally just all pointers and traversal. There's almost never any like actually algorithm. It's literally just maintaining the pointers. And then this is just standard backtracking, literally as standard as it gets. So yeah. Yeah, I guess no mistakes, and got everything pretty quickly. Once again, if this was like some competitive programming thing and I just went for getting the right thing, try to get the best time, could have honestly done it in like 6-7 minutes or something. I don't know, pretty fast. But obviously good enough. Code was pretty clean, didn't have any mistakes, or like some small stuff, but yeah. Yeah, I mean, definitely the easiest one I've done so far. Definitely wouldn't expect this one. But it is what it is. So yeah, I guess we're done with this. So I'm probably going to go back to doing system design videos, I think. Try to finish up most of the Hello interview stuff. I guess I have the mock of doing the elite code system design, if you've seen that already, with an actual person. So I'm going to skip that one, and then I will go to the rest of them. I think there's like 10 more or something. So yeah, I can do some of that. Do some more great front end now that I took a decent enough break from that. And then do daily problems, stuff like that. Maybe do some contests or something. And then let me know if you have anything particular you want me to do videos on. And then also, the other thing I wanted to do more of is mocks with real people. So that'll be kind of fun. So yeah, gonna do some more mocks with James probably, and then some other people. And then if you're interested in doing a mock, and you're okay with me recording it, if you have an interview with like a big company or something, you can definitely let me know or join the Discord or message me or something. Happy to do that. So thanks for watching.